notice no horizontal force right applied to the system. Okay, I'm not talking about the bead or the hoop itself. I'm talking about the floor. The floor is frictionless. Okay, that means there is not going to be any additional force going into the system. That means this is a two object with what? With horizontal forces being action and reaction. Remember how we derived the conservation of linear momentum, right? So if every time, if at any moment, all of the forces in the system are action and reaction, then the total impulse of those two forces must equal, which means the two objects should be forming a system with conserved horizontal momentum. But be careful, not the vertical momentum. We can, the vertical momentum is not conserved, but the horizontal is. Okay, horizontal momentum is conserved. So our solution is horizontal, and that's enough. Horizontal momentum is conserved. Okay, you see, this is a okay. This is the thought process we should have. Don't try to figure out how the bead and the hoop will move with respect to each other. It's too complicated. I mean, I can't imagine what's going on, right? How the object is moving, how the system is moving. It's very hard, but it doesn't really matter because horizontal, the conservation of momentum really care about the 2 points, right? I have the first point, right? The initial point, the total momentum is m times 2 meters per second, right? That should equals the last moment. The last moment, what we know is the bead will stop moving with respect to the hoop, meaning the two have the same velocity. So it equals to 2m, well, 2m because they have the same mass, right? Times my final velocity. It's very straightforward for me to know that final velocity is 1/2 times 2 meters per second, which is 1 meter per second. Okay. Now, but this doesn't seem to solve everything, right? We need something else. What is that something else? The system, the bead, when it's moving, you say, one more thing. Let me see. At some point stop moving. Huh? It didn't mention it explicitly. Okay. Oh, there you go. There you go. Slide frictionlessly. That's what I need. Okay. What does this mean? It means the whole system does not lose mechanical energy. Right? Because the only way it can lose energy is due to the friction. But there is no friction between the floor. There is no friction between the bead and the hoop. There is simply no energy loss, which means mechanical energy conservation. Okay, now let's think about this. What does this mechanical energy conservation means to us? At the very beginning, what is the total energy? Now, one thing I know, the gravitational potential energy of the hoop will never change because the hoop doesn't move up and down. So originally, let's assume the total system energy. I'm going to assume the hoop has 0 gravitational potential energy. The bead, assuming the bottom of the hoop is 0 gravitational potential energy. That means we only have 1/2 times m times 2 meters per second square. That's the total energy of the system initially. Now, by the end, I have 1/2 times 2m times 1 meter per second square, right? That's my final kinetic energy. But if you notice, this 2 would not equal. You will lose something. And that missing energy has to be compensated by the gaining of potential energy of the bead, because only bead can gain potential energy. So it must equal to bead the mass, the gravitational acceleration, times some height change. The height change meaning the change from this initial point M. Okay, so what I imagine the system is at some point the system will behave this way. The beat M may be here, okay? The whole thing will move with 1 meter per second, and the distance, this is delta H. Because of the energy is conserved, this must equal, right? So I can find what is delta H. Let's try to solve it. So G times delta H, let me do this. Delta H equals to 1/2 times, M is gone, all of the M is gone, times 4 minus 1/2 times 2 times 1 divided by G, that's 10. Okay, not too bad. So I have, that's 2 minus 1, so that's 0.1 meter. 0.1 meter. Do I have a, 1 second, what's the, is there, no, through what angle along the hoop has the, what's the total, what's the, is there any place? Oh, there. I'm trying to look. Okay, over here. Yeah, the radius of the hoop is 20, right? So this is 20 centimeter. Okay, now I know this is 10 centimeter. Okay, now what I want is this angle, right? If that's 10, then I can do this. Okay, do this. That's a 10, and this is 20. Okay, I should mark this one. This is 10 centimeter. Okay, so that's what, meaning this is 30 degree. So this is 60 degree, right? So this is 60 degree. A result should be 60 degree.